Hello class, welcome to another Geogebra class. So in this class, we'll be looking at the binomial and the normal distributions. Okay, we'll look at both the normal and the binomial distribution. So we'll start with the normal distribution and then we'll end with the binomial distribution. So we know that the normal distribution is it's also known as the Gaussian distribution, okay? And it's a fundamental probability distribution in statistics. Okay, so it uses continuous data. Okay, but so you can use GeoGebra to solve normal distribution questions, and that's what we want to look at today. Now, to begin with, we have to open the statistics interface, and it is known here as the probability calculator in GeoGebra. So you can do that by coming to View and then selecting probability calculator here. Then after a while, it will open on the right side of your interface here. So this is the probability calculator here, okay. And then if you don't want the graphics view, you can close the graphics view and then the algebra view, and then enlarge the probability calculator so that you have a full view, okay, of the probability calculator. You can start working with it. Or that's one way to open your probability calculator. Or you can come to this far right side here in the middle. You see a small arrow here. Just right click it, and then select probability. And what that does is that it will open the probability calculator in full view by automatically closing the graphics view and then the algebra view. And you need to open this the probability calculator for you here, okay? And that's my preferred way of opening the probability calculator. All right, so what we have here is a probability calculator. And as you can see here, it is set to the normal distribution. Okay, when you come over here, you see normal here. That means we have the normal distribution here. We are going to be working with normal distribution, and then what is drawn here is the curve of the graph of the normal distribution. You can see clearly the characteristics, some of the characteristics that we know of the normal distribution. The first one is that it is bell shaped. So you can see this looks like a bell. Okay, it has a bell shape, some sort of a bell shape. Okay, and then the parameters, you see that the normal distribution deals with the mu and then the standard deviation. Then when you have these two things, mu and standard deviation, you can calculate the probability of anything. Okay, for example, x lying between two values. Okay, and that's the default one that the GeoGebra has opened for us. So based on your question that you have, you will start changing it, some things here, and then you'll be able to get the answer that you want. Okay, so now what we have here drawn here is what we call the standardized normal distribution. And that one, the standardized normal distribution has the mu to be 0 and the standard deviation to be 1. Okay. All right. So we know that the normal distribution is symmetric about the mean. So that means you always find the mean at the center of the curve. So here the mean is 0, and that's it here. And when you draw a line here, you realize that it will be at the highest point of this curve over here. So the mean is the point of symmetry for this normal distribution. Okay, it's symmetric about the mean. Now there were other things too that we said about normal distribution. Some of it says that approximately 68% of the data falls within one standard deviation of the mean. Okay, and that is even the basic one that GeoGebra, when you open your probability, GeoGebra already shows you that, and you can see it here. So we know the standard deviation shows how far a value is away from the mean. Okay, so here the standard deviation is 1. So that means we are 1 standard deviations away. Okay, that's 1 here, -1 here. It means that this one here is 1 standard deviation away from the mean. This -1 here is also 1 standard deviation away from the mean. So when you see the probability here calculated for the data that is between 1 standard deviations away from the mean, you see we have 0.6827. That's around 68%. So that's why we say 68% of the data falls within 1 standard deviation of the mean. So when we want to check the amount of data that falls between 2 standard deviations of the mean, since this is the standardized deviation and the standard deviation is 1, 2 standard deviations away from the mean will just be 2 and then -2. So from 2 to -2, when you press enter, you see that 95, so 0.95 in percentage, you get 95%. So you can, that's why we say approximately 95% of the data falls within two standard deviations of the mean. So these are things that we learn in class, okay? And in GeoGebra, you can calculate it and verify it using the GeoGebra probability calculator, and that's what we are doing right now. So in two standard deviations in the mean, you realize that 95% of the data falls within two standard deviations of the mean. And then the last one is that is 99.7. So we want to see how many standard deviations will give us that away from the mean. So we've done 1, 2. Let's check for 3. When you do 3, you'll be able to verify the third one, which is 0.9971. So three standard deviations, within three standard deviations of the mean, you see that approximately 99.7% of the data will be there. Okay. And these are key points in the normal distribution. So we use them, these three key points a lot. That's why we take note of those three things. All right. So let's say you have a question. How do you go about it using the probability calculator to solve normal distribution questions? So before you move to the questions, let me explain something. So this is a standardized normal distribution. If the question is it's not in the standardized one, you just have to input your name and standard deviation here, and GeoGebra will still be able to solve your question for you. And if you can convert things also into the standardized form too, then you can use the mean zero and standard deviation one, and you'll be getting the same answers. So what we want to look at is the four buttons over here, and that's what will be helping us solve our questions. Okay. So the first one here is finding the probability that a mark or a value here, an input is less than or equal to a particular value. So you input a value here and then it will calculate the probability for you. Okay. And whenever you change these things here and you input a value, let me say 4, you should always press enter before it will do the calculations here for you. But okay, otherwise you'll be using the previous value probability gave you. So you must press enter whenever you input a value inside. Don't forget that. So based on the question, this one says the first one is used for maybe for x less than or equal to something. So maybe at most it's if you translate into English to be like at most 2. So that would be x less than or equal to 2. And then the second one is between two values. Okay. So when you have two values and you're looking for the mark or the value that lies between two values, all the values that lie, the probability of a value lying between two values, you use the second one. And then the third one is used to calculate one side and then another side. Okay. So if that is what you are required, you can. So for this particular third one, you can either use the second one to find the in-between parts, okay? And then you subtract it from 1 to get the shaded portions here, if that's what you're looking for. Or you use the third one, which will automatically calculate this side, the left side, and then it will calculate the right side for you. So you see there's an addition here. So when it's done with the left and the right side, it will add them for you and you get the probability. Okay. And the last one, as you probably guess, is for the um, right-sided. So if it is right-sided, the person is asking for the right side, that's maybe at least something. Then you're going to use the last one, and that will give you. So you see, you can drag here to even move the shaded portion where you want to calculate to a particular side that you want. But as you can see here, I'm trying to put it at 1, but inside my box here, you can see it's not exactly 1, 0.98068. It's not exactly 1. So that's why it's not advisable to be using this feature to try and put it at a particular value. Always input the value here because it may not be at exactly the value you want it to be. Okay, so use the input field here to do the calculation. All right. So let's pick one question and then use this probability calculator to solve it. And then we move on from there. All right, so I have a question here. It says IQ scores are normally distributed. So once it's normally distributed, we can use this probability calculator for normal distribution in GeoGebra to solve it. So they are normally distributed with an average of 100. We know the average is always the mean. So the mean is 100. So here I won't use the standardized normal distribution. I'm going to input the values just like that. So the mean 100. So the average of 100, and the standard deviation is given to be 15. So the standard deviation is given to be 15. So 1, 5, enter. All right, now on the question. The question says, how likely is it to have an IQ score of 120 or higher? 120 or higher. So 120 or higher, it means we are looking for at least 120. Okay, at least 120. And that one, the last option here, that's this one, is the one that we're going to use. Okay, so here we are going to input 120. So we want all the x that is greater or equal to 120, and then always make sure you hit enter after inputting your values in, and now you see it is updated and we have it at 0.0912 or 9.12%. Okay, so this is how you use a probability calculator to solve normal distribution questions. All you have to do is to input your mean, your standard deviation, and then pick one of these options here based on the question asked. Okay, and then you'll be able to solve it. So if the question has asked for a region that is not directly one of these four, then you will have to maybe play around it to get what you want. Okay, for example, maybe here it was asking for between 120 to 130. Okay, just the area between 120 to 130. Maybe that's what the question asks for. You can use this option here, that's the second option here, and then 120 to 130. Okay, you hit enter, and then we have that here. Or you can calculate, you can use the right side, this one, to calculate from 120 to the end, okay, to give us 0.0912. And then when you write that value down, then you also calculate from 130 to the end. Okay, so that one is 0.0228, and then the difference between the two, when you subtract the one you got from the 130, that's this one from the previous one, that will give us the area between here, that's 120 to 130. Okay, so that one is just application of mathematics to know, you should be able to know that and do that. Okay, so there are four options here, but if the question asks in a way that these four options are not directly applied, you can play around with it and find a way to still use these four and still be able to get what you want. One of them might be able to help you get what you want. All right. So we'll come back a bit to the normal distribution, but let's move on to the binomial distribution. So with the same probability calculator, here at the portion here where it says normal, the arrow here, you can click on it, and you realize that there is actually a lot of distributions here that GeoGebra can work with. Okay, so the normal distribution is just one of them. We have the student test here, the chi-squared, F distribution, exponential, Cauchy. All of these distributions, GeoGebra can help you to solve questions on them. So all you have to do is to click any of them, and then GeoGebra will show you the parameters that are needed, and then the question, what the question has asked you for, and then you input it and you'll be able to calculate your probability. Okay, but today our focus is just on the normal distribution and then the binomial distribution. So as I'm going to select binomial here, and we get this here. Okay, all right, so a little bit about binomial distribution. We know that the binomial we know that binomial distributions are for discrete data. Okay, so it's a discrete probability distribution that it describes the number of successes in a fixed number of independent trials. Okay, so binomial distribution fixed, it deals with discrete data that describes the number of successes in a fixed number of independent trials. Okay, so each trial has only two possible outcomes here. We only have success and then failure. Right. So there are fixed number of trials, and then there's a binary outcome. Fixed number of trials. There's maybe So this n here, okay, the parameters, this n here is the number of trials and it is always fixed. So it will be given to you in the question. That's what you'll be inputting here. And then the probability here is the probability of success, okay? And because there are only two outcomes, success or failure, the probability of success is what you're going to input here. So if they don't give you the probability of success and they give you the probability of failure, then since there are only two possible outcomes, you subtract the probability of failure from one, which is the total probability, and you'll be able to get the probability of success. So what you need to know is that the P here is for the probability of success. Okay, the small p is for the probability of success. So you must get it from the question and you put it here. Okay, then once you have fed the correct data to GeoGebra, you can now ask your question and GeoGebra will do the calculation for you. So as usual here too, there are four options here, just like the normal distribution. The meanings are the same as the one for the normal distribution. The addition here is the table here you see over here. Okay, so whenever you have the number of trials here, the fixed number of trials, when you input it here, GeoGebra will calculate the probability for each of them. And this is something you would have done if you were working with, if you were solving it on paper. You would have worked out all these trials and then you use it to answer whatever question that has been asked. But GeoGebra is doing this for you here. It has worked out the probability for of success on each of these trials. So you have it all here. So if the question was direct, maybe find success rate at maybe 5 trials, then you get it here at exactly 5 trials, then you get it at 0.0148. Okay, so if it is not exactly a particular number and it is between a range or at most or at least, then you can use the four options here. So the first one is at most, so maybe at most 5 trials. So then our value here will be 5 and hit enter, then it gives you at most 5 is at 0.0207. Okay, that's the probability. Then in between two numbers is here. Then we have the two-sided. Okay, so one side and then another side here. And then the last one is the left, the right side, completely on the right side. Okay, so those are the options as well. So let's pick one question to under the binomial and let's see how it goes. So you know that the binomial, you see the button, the buttons at the top here. Okay, when you click on the red one here, it shows you the normal distribution curve, okay, how it relates to the binomial. So as the number of trials increases, the binomial curve becomes or gets closer and closer to a normal distribution curve. Okay, an example, when I use 1,000, 1,000 trials, you see that there are so many of them here that it is almost looking like a normal distribution curve. All right. So um, let's move back to the 20. All right. So let's remove this option and let's solve one question two under the binomial. And let's see how you can use GeoGebra to solve it. All right. So I have a question here. So the question says that so okay, let me use this other question here. Okay. All right. So in this question, it says that suppose an hacker can hit a bull's eye 70% of the time. So that 70% of the time there is a probability of success. Okay. So this one is in percentages, so we must convert it into decimals, and 70% will give us 0.7. So that's 0.7. So that's the probability of success. So the probability of the hitting the bull's eye is 70%. So we should assume that each shot is independent of the other. Okay, this is all conditions for binomial distribution. Okay, the shot has to be independent of the other. Okay, now if he shoots 10 arrows, so the number of trials is 10. So you're shooting 10 arrows. All right, so now we can now move to the question. So once I hit enter on the 10, you see that GeoGebra has already calculated the probability of each trial here for me up to the 10th one. Okay, so the question was to find the probability that he gets four bull's eye, the probability that he gets four bull's eye. So four is, you don't even have to come down here to use this. You can just pick it up here. Okay. If you get four, the probability that you get four bull's eye is just here at 0.0368. Okay. If it was the probability of getting at most four bull's eye, So that one is the one you would have used the first one here. That's x up to 4. Okay, at most 4 goes I, then you get the value here. So when you hit enter, 0.0473. And what this value here is giving you is the addition. So you see, Geogebra has highlighted the part that it's working with in blue here for you. So 1, 2, 3 up to 4. So from 0 to 4, it has highlighted them. So what it does is it has added all these probabilities here. And the final sum is what is giving you here. And that is what we do when we are calculating it on pen, using pen and paper without any calculator, okay? But GeoGebra is doing all these calculations for you, so it's making everything very easy for you. You just have to know how to do it. So you just need to get your probability right, get your number of trials right, and then based on the question, you just choose one of these 4 options, and you'll be able to get your calculation and get the probability. So this is how easy it is to work with the GeoGebra probability calculator. Okay, it's very, very easy. All right, so let's move to the back to the normal distribution. Now, suppose you want to move this from here to your from the probability calculator to your graphics view. When you right click on any portion of the space here, you can see 3 options there. So the one you want is copy to graphics view. When you hit copy to graphics view, it will take a while, but GeoGebra will copy it to your graphics view. So here, my graphics view is not opened, so it will not automatically open. So I need to go to view and select graphics, and now I can see my graphics view here on my right. Okay, so if I don't want to be working on the calculator anymore and I want to now start working with something in the graphics view, I can just close this, and now I have my graphics view here. So it has removed the grid. So I bring it back, and then we have it here like this. Okay, so I can also bring back my algebra view to see the parameters that I have here, and I'll set the sort object to object type. All right, so I have a function. So this is the function for normal distribution. It is already here. Okay, then we have some numbers here as well, and then some points here. Okay, so this is the normal distribution exported into the graphic sheet, and then when it is here, there are things you can do. You can play around it and stuff. For example, we can insert a slider into this. To do that, you have to double click here. But even before that, let's set our parameters. Okay, so um okay, my input field, you can see my input field. So let me, okay, so the input bar is here now. All right, so let's say we want to insert a slider into this and see how the mean and the standard deviation affect the normal distribution. So I will set my mean to 1. So mean is equal to 1. And then I'll set my standard deviation also, which is sigma, also to 1. And now I can go to my function. Okay, so we know the formula for the normal distribution. We know that it's absolute of the standard deviation. So the absolute part, so instead of 1, I will insert my standard deviation symbol, which is sigma. And then we know at the top, the numerator, we have x minus the mean all squared. Okay, so I will go to the x part, and then I will do x minus the x minus mean mu. Okay, so x minus mu. Okay, then I'll hit enter. All right, so my sliders are created. Now I can bring out my sliders. Okay, now when I move mu around, you see the graph is moving also. Okay, so we said mu is the center of the distribution, so it's the mean is at the center of the KF, so it determines the symmetric part. Okay, so the curve is symmetric around the mean. So that means as I move my mean around, the curve will also be moving around, since the mean must be at the middle part of the curve. Then the standard deviation determines the spread of the distribution, how spread the distribution is. So if I move my standard deviation to much higher values, the spread now is so spread, the graph comes down. Okay, it's like it's getting flatter and flatter. But the thing is that it will never touch the x-axis. It can never touch the x-axis. That's what we call the horizontal asymptote. Okay, because it can get larger and larger and larger, but it can never touch the x-axis. And because of the absolute sign, even when I move to the negative part as well, I get the same results. Okay. Now, this one can never be zero. The spread can never be zero because even in the formula, when it is zero, you will realize that the denominator is going to be zero, and in mathematics, that is just going to be undefined. Okay, so sigma can never be zero. Okay, all right. So this is some minor things that, or some of the things you can use GeoGebra to do. Okay, so you can practice more on it, and then you can also check out the other distributions, the various distributions as well, all the other distributions, and you can play around them and solve some questions on them as well, and then see how it is. Okay, so today we're ending the class here, right? So you can see as the mean and the standard deviation moves, see the curve is also moving. Okay, it's also moving with respect to that. All right. So thank you very much, and I hope to see you in the next class. Thank you.